Hello everyone, welcome to Siddhi Academics. I'm Amrita. I firmly believe that you should keep trying and you'll get it right. Let's start our trial for today. Let's understand lines and angles from class 7. Now if you learn this very well in class 7, then you will not find any difficulty in class 9 and 10, because directly you will get these fundamentals coming up in class 9 and you'll be wondering what has just happened. So do it, learn it well in class 7 and you will be not regretting the decision. So if you are watching my channel and like it, then please like, share and subscribe to my channel Siddhi Academics. Let's start. Let's learn Introduction to Lines and Angles for class 7. If you learn it very well right now, then going ahead in grade 9 you will get the same concept, same everything put there in class 9, and from class 9 you will get in class 10th. If you do not understand it now, then you will find great difficulty in your 9th and 10th. So if you learn it now very well, you can easily solve the questions from class 9 for lines and angles now. So let's start with a brief recap of whatever we have learnt for this particular chapter. So let's start with a point. A point is a geometric element that has no dimension. It has no thickness, no length, no width, nothing. Okay, it's just a point. That kind of geometrical element which has no dimension is a point. Now, what are collinear points? Points which are on the same line are called collinear points. Like this is a line here, and point A, B, C lie on the same line. So these are called collinear points. Non-collinear points. Points which are not on the same line are called non-collinear points. Like here P, Q, R, S. If you try to put them in one line, no, they won't come on a line. They may come in a quadrilateral, but that will not be a line. So these lines here, these points here P, Q, R, S can be considered as non-collinear, and these points A, B, C which lie on one line are called collinear. Linear word comes from line. So collinear means points which are on one line. Non-collinear means those points which are not on the same line. Now let's understand further what is a line. A line is a straight path which travels infinitely in both directions. See here, I have given this line name A and B, but A and B are not the end points of this line. If you keep on extending, this will infinitely go in this direction, and in A's direction also. If you move ahead, it will go ahead and not be ending anywhere. So it will go on infinitely. So that kind of a straight line or a straight path is called as line. Now line segment, a line segment is a straight path which has two endpoints. Like here E and F, these are the two endpoints, right? So that means this line segment EF is a part of a line. If you extend like this on this side and you extend this line segment on this side, then what you get is a line. Okay, so this entire line has a part, that is this line segment EF, which is a part of this line. So this any line segment is any straight path which has two endpoints. Now what is a ray? A ray has one endpoint on one side and extends to infinity on the other side. Like O is the endpoint here. It does not go beyond O on the left hand side, but it extends on the right hand side. A line, a ray could also be like this. Endpoint will be on the right side and it will extend on the left hand side infinitely in the left hand side. So that also could be a ray. Now let's understand different types of set of lines. The different types of lines that we encounter. Vertical line, which are standing line, horizontal line, sleeping line, slanting line, neither sleeping nor standing. They are like a slide, like a ramp. Okay, slanting line. Parallel lines. Parallel lines means distance or gap remains the same between the two lines, no matter how much you extend in either of the directions. They will never cross each other, right? So these are a pair of horizontal parallel lines. These are a pair of vertical parallel lines. You can also have a pair of right any direction. They are never going to meet. The distance between them is going to remain just the same. Intersecting lines, they share exactly one common point, that is called as point of intersection, O. Okay, based on this we are going to learn so many different types of angles going ahead. So these are important lines. If you still don't remember parallel lines, intersecting lines you are going to come across, and we will learn also different kind of angles where parallel lines are intersected by another line. So we'll go ahead. So just keep an eye on all of this. Remember all of this. Now let's have a look at angles. An angle is formed by two rays when they join at a common point. When they intersect two rays which start from a common point, they form an angle, right? This is the angle in between the two rays. So let's see what types of angles. We have already learnt it before also from grade 5. Acute angle less than 90 degree, it's not even 90 degree, I think from grade 4. So it's less than 90 degree, could be 45, could be 75, could be 89 also. All of these will come under acute angle. Right angle means exactly equal to 90 degree. That angle is called right angle. Obtuse angle greater than 90 and less than 180 means 91. If it is just 1 degree beyond 90.5 also, 90 degree 1 minute also, then also it is an obtuse angle, and it should always be less than 180 degrees. So 179 degree angle is also an obtuse angle, not a straight angle. Now a straight line, two rays when they form a straight line, then the angle formed between them is a straight angle which is exactly equal to 180 degree. So 90 degree we saw its counterpart, sorry, 90 degree we saw right angle, and its counterpart is straight angle 180 degree. Then we have reflex angle, the angle greater than 180 but less than 360 degree. And what is that 360 degree? When the ray, one of the rays goes, makes a full complete rotation and falls back onto, coincides with the other ray, then the angle thus formed is called as a complete angle, right? Because that angle is equal to 360 degree. We can see this complete rotation of one ray and then it falls back on or coincides with the other ray. So this complete angle is also equal to 360 degree. Okay. So we learned acute angle, right angle, obtuse angle, straight angle, complete angle and reflex angle. 6 different types of angles. Now let's have a look at complementary angles example as well as supplementary angle examples before we go ahead and solve some questions, just so that your memory gets refreshed if you do not remember as of now. So see here, the clock is exactly striking 3 o'clock, the hour hand, the minute hand, and the second hand is between those two, hour and minute hand. Now the angle formed here and the angle formed here, what do you think? Together how much they will, if I try to find the sum of these two angles, how much will be the sum? The sum will be exactly equal to 90 degree, right? If I take this as angle 1, this as angle 2, then angle 1 plus angle 2 will be equal to 90 degree, because the minute and hour hand are exactly striking a right angle here. So these two kind of angles are called complementary angles. Okay, this word complementary stands for a pair of angles which for together form 90 degree. Similarly, you can see a pizza here, and these two slices, if you take any two slices, you can take these two slices as well, not a problem. If you want to take these two slices, they are forming 90 degree. So these two slices here are exactly, if cut exactly in a similar, I mean with similar measure, then they will be forming 45 degree this side and 45 degrees this side. Here see, it's 90 degree here. So this angle here will be 45 degree and this angle here also will be 45 degree. Okay, so these two angles are also complementary. Now let's have a look at supplementary angles. Have you seen roads making a Y intersection like this? Y intersection, where the road, either you can choose to go on the straight path or you can take a left turn towards this side. So those kind of Y intersections also are supplementary angles. This angle here, I'll just erase this, it's not looking nice here. This angle here and this angle here on this side of the road, these two are supplementary angles. Why? Because these two angles, let me say 1 and 2, angle 1 and 2 are making 180 degree. They are making a straight path. They are making a straight angle. So these are any pair of angles which form a straight angle are called as supplementary angle. Similarly here, the laptop and its shadow, together they are forming a straight angle, that is 180 degree angle. So these pair of angles are called supplementary angles. Okay, now see some questions we have. Yes, an angle formed when two rays join at a common point are angles. We know that. Now complementary angle,
here we see angle MON and angle NOP are 90 degrees. So suppose this is given as 20, then I can easily find angle MON. MON will be 90 minus 20, which is 70 degree, right? So this angle here will be 70 degree. Similarly, if the question has given this angle, let this be equal to 120 degree. We are talking about supplementary angles now. So angle POQ we need to find. Then how much it will be? Because these two are supplementary angles, so I can just subtract this 120 degree, that is angle QOR, from 180 degree to find angle POQ. So it will be equal to how much? It will be equal to 60 degree, right? So this angle here is 60 degree. Easy to find out. If we know that a pair of angles is supplementary or complementary, subtract from 90, find the other angle, subtract from 180 for the supplementary angle and find the other supplementary angle. Okay. Now what is the complement of 45 degree? Very easy. 90 minus 45 will always be 45. 45 degree is just half of 90 degree. Similarly, 37 degree. So 90 minus 37 will be 3 comes here, 10 minus 7 becomes 3, 8 minus 3 becomes 5, 53 degree here. 59 degree. So 90 minus 59 will be 31 degrees. Now similarly, supplementary angle we have to find. What is the supplement of 57 degree? So 180 degree minus 57 we have to do. So that will be 10 minus 7 is 3, 7 minus 5 is 2. So this is 123 degree. Similarly, 180 degree minus 1 to 1 we need to do. That will be 9. That will be 5. 59 degree. 59 degree will be the supplementary angle, which is the counterpart of 121 degree. Similarly, 180 degree minus 170 degree will be 10 degree. Solve this question. Understood how to do? I think there will be no doubts. What is the measure of complementary angles whose difference in measure is 20 degree? Okay. So there are two angles whose difference in measure is 20 degrees. So x and 90 minus x, these two, if we subtract these two, what we are getting is 20 degree of difference in the measure. So how to find out the measure of these complementary angles? So one is x, other is 90 minus x. So if we find the difference, it will be equal to 20 degree. So now let's solve. Let's open this bracket here. So it will become x plus x minus x is plus x. So x plus x becomes 2x, and then minus 90 equal to 20. So 2x is equal to 90 plus 20, which is 110. So x is equal to 110 by 2, which is 55 degree. So one angle, if it is 55 degree, 90 minus x will be 90 minus 55, obvious. So that is 35 degrees. So these two angles, 55 and 35, have a difference in measure of 20 degrees, and also these are two complementary angles. Okay. So by and by, as you solve, you get more and more proficient in this. Now let's understand adjacent angles. Two angles are said to be adjacent angles if they have a common vertex, like here O, common vertex O. They have got a common side, like this angle here and this angle here have a common vertex O and common side OB. And one more important point is the two other uncommon arms are on either side of the common arm. Means OA and OC we can see are on either side of OB. So in such a case, we can say that the angles are adjacent angles, and it is not necessary that adjacent angles will be equal to each other. If this common arm OB is an angle bisector, like for example a 90 degree angle is there and there is an angle bisector like this, okay, then the angles, these angles, two angles, let me name this first. Yeah, this angle 1 and angle 2 each will be of 45 degree. So in such a case, OB I have said is an angle bisector. Angle bisector means it divides the entire angle into two equal pieces. Okay, so if it is 90 degree, angle 1 and angle 2 each will be 45 degree, right? So in such a case, this kind of adjacent angles can be considered as having equal measure. Suppose not 90, some other angle, 120, 130, you take it, name it, and the common side is an angle bisector. In such a case, adjacent angles will be equal in length, but in all other cases adjacent angles are not equal. Okay, we just got to know which angles are called adjacent. Now some real life example, look at this design above the door. What is it called? I am not sure. Door pan, something to and let the light enter. If you can see this two, these two lines, they are forming an angle of, I think, 90 degree, and this line here is like acting like an angle bisector, and this is the common side, this is the common vertex here, let it be O. Then these two angles here are, I can say, definitely adjacent angles, right? Similarly, you can take this line, and then we can get these two as adjacent angles, because this line will act as a angle bisector. Any number of angles you can see here, you can form any number of angles here, and we can get them as adjacent. Okay, like this also, this here, these two are, this is an angle, and if this is the common side, then this angle here and this angle here are adjacent angles. So real life examples, real life scenarios, you can get any number of them. Okay, so here it's written that angle COB and angle BOA are adjacent angles because they have a common side OB and have a common vertex O. Now let's understand what angles are not considered as adjacent angles. Let's look at the first example here. Here you can see two angles, angle 1 and angle 2. Here the common side is OA, or definitely both angle 1 and angle 2 share this side OA, but it is not lying in between these two uncommon sides OB and OC. Here angle 1 and angle 2 are overlapping each other, right? So in such a case, we cannot consider angle 1 and angle 2 as adjacent angles. Now let's see this example here. Angle 1 and angle 2, they are not having a common vertex, right? Here it is having O, here it is having M as the vertex. So they don't share a common vertex. So in such a case also, angle 1 and angle 2, these kind of angles cannot be considered as adjacent angles. Now here you look, angle 1 and angle 2. What is the problem here? They don't share a common side. They have both of them have got different uncommon sides. So in such a case also, these kind of angles cannot be considered adjacent to each other. All right. So now that we have understood, let's solve some more problems on adjacent angles. Question is that, can two adjacent angles be supplementary? This is to further understand your concept of about adjacent angles. Yes, of course, a linear pair of angles. Linear pair of angles means two angles which form a straight line. When they are together, form a linear pair, they will obviously have one common side, a common vertex, and uncommon sides will lie on either side of it. So two adjacent angles will form 180 degree and hence can form 180 degree and can be supplementary. Similarly, here we can see an example of two angles which are complementary, means if you add them up, they form a 90 degree, right? So these two angles can be considered as complementary because they have a common vertex, let's say O, and a common side OA, and two uncommon sides OB and OC are lying on either side of this OA. Now let's consider this one. Can two obtuse angles be adjacent? Of course they can be. If this angle 1 and angle 2, both you can see in this figure, are more than 90 degree, right? They are definitely both angle 1 and angle 2 are more than 90 degree, and they have a common side here. Let me name it, let's say OP, and then they also, the uncommon sides are lying on either side of the common side. Okay, OQ and OR are lying on either side of the common side OP. So these two angles, obtuse angles, can be adjacent. They together will make one reflex angle. That we have to keep in mind, because two obtuse angles together generally will form a reflex angle. Now, can an acute angle be adjacent to obtuse angle? Yes, we can see in this first figure here. There is an acute angle less than 90 degree here, and there is an obtuse angle on the other side, and both of them are adjacent to each other. So with this, I hope your concept on adjacent angles is clear. Alright, and you won't make any mistakes. What's a linear pair? Two adjacent supplementary angles whose non-common sides form a straight line are called linear pair. अब उसका मतलब क्या है? See here OC is the common side, but the OB and OA are forming, these are the uncommon sides, they are forming a straight angle, 180-degree angle. So that is why these two angles, angle AOC and angle COB, which are adjacent as well as supplementary, these two angles are called linear pair. So linear pair, two conditions: they have to be adjacent, they also have to be supplementary, that is they have to form a straight line together. These two angles must form a straight line, then only they will be considered as a linear pair. Similarly here, angle COB and angle DOA, they or AOD, however you want to say it, are not adjacent. Why? Because they are not adjacent, though together, if you see, let's say this is 60 and this angle here is 120, they are forming 180 degree, means they are supplementary angles, but they are not adjacent to each other. They don't share a common side or a common vertex, nothing in common between them. That is why they cannot be considered a linear pair. So hope I'm clear. They have to be adjacent, they have to be supplementary, they should form a straight line, that means, which then only they will be considered as a linear pair of angles. Now what are vertically opposite angles? Vertically opposite angles are formed when two lines, remember clearly, two straight lines intersect each other, they cut each other at one common point. Then the angles opposite to each other are called as vertically opposite angle, or in short we say it as VOA, vertically opposite angle. See here angle WOY and angle ZOX are vertically opposite to each other, right? Similarly here these two angles YOX and WAZ are vertically opposite to each other. How they have formed? Because angle WX, line WX and line YZ intersected at this common point O. That is how they are formed, and we always remember two vertically opposite angles are always equal to each other, which means I have written here this, let's say this is angle 2, this is 1, this is 3 and 4. Here angle 2 will be equal to angle 4 in their measure, okay, angle 4, and angle 1 will be equal to angle 3. That means if this angle here is, let's say, 120 degree, this angle 3 will be also 120 degree, and angle 4, if it is equal to 60 degree, then angle 2 here will also be equal to 60 degree. Okay, very important. By using vertically opposite angles, we will be able to solve some questions where one angle is given and we have to find many other. So please remember this concept, formed by two lines. I have also taken this example of two rays, not two rays, four rays which have intersected at this common point O. They have started, all of these rays have started from the common point O, OQ, OS, OR, OP. They do not make vertically opposite angles. Why? Because they will not be equal to each other. You can clearly see here this angle 1 is not equal to angle 2. Similarly, angle 3 is not equal to angle 4. So two straight lines have to intersect. They have to cut each other to form vertically opposite angles. And rays do not make VOA or vertically opposite angles. Okay, so let's understand all these concepts clearly before we move ahead and understand parallel lines and transversal and all those things. Okay.